Now let's talk about spherical coordinates. Given points A, B, and C here in rectangular form, we need to find spherical coordinates. So first off, we have to know what that means. So that means we're going to find rho, theta, phi. And how we find this is just plugging in this x, this y, and this z. So my x is -1, my y is 2, and my z is 1. And I'm just going to plug that into this formula first. So I have rho squared. That's the one I want to use first. And that equals x squared, so that's -1 squared plus 2 squared plus 1 squared. And remember, here's my -1, here's my 2, and here's my 1. And that's going to give me 6, which means rho then is square root of 6. So I have my first coordinate here, which is square root of 6. Now I need to find phi and theta. Now, since my z is 1, which I can see from here, I can find phi now. So what that means is I'm going to use this equation here. So that means my z, which is 1, is going to equal my rho, which is 6 cosine phi. And then what I have to do here is move over the square root of 6, which this gives me cosine of phi equals 1 over square root of 6. And then I cosine inverse both sides. So my phi is actually going to equal cosine inverse of 1 over root 6. So there's my phi. That's the last one there. Now I have to find my theta. So to find theta, I can just use this tan of theta equals y over x, which is here. So that means I'm going to have tan of theta equals, and my y is 2, and my x is 1. So my theta is going to equal tan inverse of -2. So now I have my 3 coordinates here for this first spherical coordinate here. And that's going to be, now sometimes the book will require a decimal approximation for these. So for this phi here, it's approximately 1.15. And then for my theta here, my theta is going to end up being 2.03. Oops, let me fix my 3 here. And that would be my phi. So then my theta, excuse me. So then my point then, my rho, which is square root of 6, comma my theta, which is tan inverse of -2. And then my phi, which is cosine inverse of 1 over root 6. So there's my ordered pair. Or you may put square root of 6, comma, 2.03, comma, 1.15. So there's your answer for the first one. Or I can write these in degrees, which you see here. So I'm going to keep the degrees here because that's going to make it a little easier to graph in a minute. And then we'll get to, you'll get to understand that a little bit easier if I use degrees. Okay, the next one we're going to do is number B here. So again, this is my x, this is my y, and this is my z here. And all I'm going to do is follow those same formulas. So then my rho squared is going to equal -2 squared plus 2 squared root of 3 squared plus 4 squared. And that's going to equal 2 plus, that's going to be 4 times 3, which is 12, and then plus 16. So this is going to end up being 30. And then that means rho then is going to be really plus or minus the square root of 30. But I'll just write the square root of 30 for this one. And then what we're going to do now is we're going to find theta. We can find theta next. So then tan of theta equals y, which is 2 square root of 3 over negative 2. So those cancel, and I'm going to get negative square root of 3. Now, when I do the tan inverse, or that idea of the tan inverse, where is opposite over adjacent? Negative square root of 3 over 1. And if you think about it, that would happen either in the second quadrant or the fourth. And the opposite side would have to be negative square root of 3. So that makes this 2 and that 1, which tells me this angle here is 60 degrees, which tells me this angle is 120 degrees. And then also, we can think about the angle that goes all the way around there. And that would be 300 degrees, because it's 60, because that's 60 degrees, so it's 60 degrees short. If I went all the way around, it'd be 360 degrees. So that would be 300 degrees. Now this is the same theta that goes around in this direction on the x-axis, so that doesn't change here. So we have to think about where our point's at to begin with. So our x is negative, so we're back here. It's negative 2. Then we're going to the right, 2 square root of 3, which is 3.46. So it'll be over here somewhere. So my point's going to live over here, and then it's going to go up 4 from there. So that's where it's going to be at. So it's actually going to be back here in the second quadrant. So if I was to draw this as a unit circle here, this idea here, then that would tell me that I would be in the second quadrant. So I'd be over here. So that would be 120 degrees that I'm dealing with there. So my theta would be 120 degrees. Now I need to find my phi. So now for phi, I'm going to use this equation here. Z equals rho cosine phi. So my z then is 4. So it's going to be 4 equals, and then my rho, which I calculated already, is square root of 30. Square root of 30 times cosine phi. So first thing I'm going to do is divide by square root of 30. So cosine of phi equals 4 over square root of 30. And then I simplify if I can, which I can't. So then I'm going to just take the cosine inverse of both sides. So then phi is going to equal cosine inverse of 4 over square root of 20. I just noticed a typo when I was going through this cosine phi here. I noticed that it's square root of 30 on the bottom, and that's not what it should have been. That's what threw my phi off, and I just kind of noticed that it seemed off here. This is where I messed up. So that was negative 2 squared, which should have been 4. Oops. So I have to fix this 4 here, and I had a 2 there originally. So now this isn't going to be 30 anymore. It's now going to be 32, which makes this here also 32, which actually gives me a 16 there, which is a 4 square root of 2. Now again, I should go plus or minus, but since I'm just dealing with rho here, I can just keep it 4 square root of 2. And that's what should have been down here at the bottom here, 4 square root of 2. I messed that one up, so that's what this 30 is now. That's supposed to be 4 square root 2, and then those cancel, and then this gives me cosine of phi equals 1 over root 2. And when I take the inverse of that, phi, I'm not going to take the inverse of it, I'll just say phi is going to equal, and remember cosine is positive, so that means it's going to be the first or fourth quadrant. So it's going to be pi fourths or 7 pi fourths as our answers here for phi. So now we just have to determine where we're at. So we know we're back here somewhere. So that tells me it's going to be, is that the right point? Hang on. And graphically, you don't understand phi yet, so you'll just have to accept it for what it is. And it's actually going to be this this pi force here. And we'll talk about why that is in a few minutes when we graph it. So I will keep radians for this because I do like radians actually better. So this is actually going to be 2 pi thirds here. So now I have all of my points for that. My values. So for my rho, it's going to be 4 square root 2. And for my theta, it's going to be 2 pi thirds. And for my phi, it's going to be pi fourths. So there's my spherical coordinates for point B. Now let's do point C. Now point C is 0, 3, 0, so I'm going to start the same way. So my rho squared is going to equal 0 squared plus 3 squared plus 0 squared. So it's going to equal 9. So rho equals 3. And generally I go plus or minus 3, but I'm going to keep it rho positive here. So then that's my rho, so now I have to find theta. So the tan of theta equals y over x. So my y is 3, and my x is 0, which is undefined. So that tells me right away I can't use my handy-dandy formula here. Honestly, I just kind of have to understand where it's at. So think about where 0, 3, 0 is. So it's 0, 3, 0. So it's here. That's where the point's at. So if I think about my angle is going to go all the way to there and stop. So that means my theta is going to equal pi halves. And furthermore then, for my phi, we can plug that in, okay? So my z, so I'm going to use this formula here. So my z is going to be 0. So that's going to be 0 equals, and my rho is 3. And then my cosine phi, oops, not theta. And when I divide by 3, I'm going to get cosine of phi equals 0. And where cosine equals 0 at, my phi is going to be pi halves, or it's going to be 3 pi halves. And just take my word for it, it's going to be this one for now. It's going to be pi halves. So now we're going to have some fun graphing this in the next video, and you'll see why I picked phi the way I picked phi. So now my third point, just to get everything there, it's going to be 3, comma, pi over 2, comma, pi over 2. So that's our answer for the third point.